In progress.
Hey, hello.
I definitely.
No, Teams got problem, man. Never mind. Hey, don't worry. I
I
am.
came at 9. I mean,
Oh,
earlier than 9.
oh.
You can select.
Hey, no worry, no worry. Yeah. I use Zoom. I'm using Zoom. I use Zoom. Okay. I share screen. Yeah, the thing cannot make it screen. Share. Okay, yeah. Let's see, can or not. Meeting, what's meeting? Meeting now. Okay, Kaden, can you hear me? Can you hear me? Kaden, mic check. Mic test. Can you hear me?
Oh yeah, can.
Okay, loud and clear. Okay, can, thanks. Yeah, I think Teams got problem, My
Yeah.
headphone also cannot. Yeah, this morning. I think other meeting will have issue. Okay, wow, sorry. Wow. Okay. Right, so yesterday, Oliver, 1, 2, 3, 4, 5, 6, 7, Ibrahim. Okay, sorry, apologies. Some issues with the computer. The team, I'm trying to do a recording. Later I'll post this Zoom video to the cloud, to somewhere, and then you all can access. Okay. 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 So for today, right, I'll just touch on the last part of chapter 4, mean and root mean square. All right. So these are used in statistics. Like even not just engineering, anywhere business. I think they use quite a lot. Business and business statistics they use quite a lot. Other forms of studies, not just engineering, science, finance. When say business, they include finance as well. So these are just useful tools for us, right? And um, after that, we'll look at some of the review questions, right? The tutorial plus review questions to prepare ourselves, essentially. All right. So we'll take it one thing at a time. Okay. So let me just talk about this bit, root mean square. Okay, so root. Okay, for me now, okay, look at this formula, right? Wow. What is that? What is it trying to say? Like all algebra. So basically, it's taking the average. Yeah, then root mean square would be I square each part, I mean it, meaning I get the average, then I root it. Right? So basically, if you look at this, I square the fx, right? Which is okay, I square the fx over here. I square it, I square the fx, I get the mean, which is basically this, and then after that, finally, it's the square root. Okay, so this is normally to do error analysis or trying to find how far the the each of the sample is away from the mean. How much? Yeah. Right. Normally it's like that. Okay. So you all know mean before, right? You all do average, right? Yeah. So if let's say I can do a graph, just okay. This is x. This one is my y, and then let's say I've got a graph that. Okay, this is my y equal to fx graph, and I have between values a to b, right? A to b. So I'm trying for the mean average. What it would mean is that I will end up getting somewhere along this point. All right, the mean value. Right, this will be my mean value y bar. Right, if I were to get, when I do the integral of this, right, a to b fx, I'm actually getting the area under this graph. So area under this graph, and once I get the area under this graph, I divide by the b minus a, right? Actually, I'm dividing this by the sum of the the x values. So then when I do that, I'll get the average. So that's what it means. Okay, so applying this formula, we just apply now, right? Only question now before I continue. Okay, average. I'm basically finding average. Right? I sum everything up and then I divide. So once so let's look at example 9. Okay. Example 9. Okay, example 9, we have this function y equals to x over square root 9 plus x squared. So we'll just use the basically the average formula, which is given, to find the average of this y value between x minus 2 to, right? So this is how it goes. So b will be 2, and then a will be minus 2, right? Integrate between minus 2 to 2, and then of course the function of y, right? Function of y, okay, I'll write this straight away. So this is my y function, right? Yes. So the formula is very easy now. So as in like just writing all these things. So the challenge now is how do I integrate this? With the square root, we try not to include the square root in try not to it's a complicated method. For me, I will do 9 plus x squared. Okay. So do substitute with the higher power, right? So that's a LACE. Remember late, late. So I substitute the L first, logarithm. So there's a log, I substitute that. A algebra, and higher power. So this is 9 plus x squared. So 9 plus x squared, a bit tricky because when I differentiate, right, then I get the star, then after that minus half. So a bit tricky. after algebra, then I'll use it in the transfer form. Then alpha P is, yeah, remember, okay? So once I have this kind of thing, link comes straight to mind. Okay, so in this case, I will try, like mentioned now. So, okay, look at this first. I integrate this. So let u equals to 9 plus x squared. Okay, so I want to do substitution, right? So I need to differentiate. So du dx, that will give me 2x. So now I need to observe, because I want to replace my dx with whatever du terms. Then I look over here. I observe that, okay, there's a x, there's a dx. Oh, there's a x, there's a dx. Then there's a 2. So I need to transfer the numbers around. So I'll do this. Half du equals to x dx. Alright. So now with all this, I put it back into this expression. I will then get 1 over square root u, right? And then I'll get half du. Can you all see? I'll just pause here for a while. Can you all see? Right. Okay. So then we have this, internet unstable. Kaden, can you still hear?
Okay.
Okay. Is it recording? It's recording, right? Because I can't see.
I think so.
Yeah. Or you can see the red dot or something. So let me see from my side. Okay. So anyway, okay, it's recording started.
Recording in progress.
I just want to confirm. Okay, so once we have this, right, I'll then integrate accordingly. So this will be u minus half, right, du. Okay, so how would this turn out? It will then become, okay, the thing is, I also want to put in my u values. So when x is 2, my u is 9 plus 4, 13. When x is minus 2, u is again 9 plus 4 equals 13. So it's like 13 minus 13. It will be 0, 1. Yeah, so it's kind of lame. This question you asked me. Okay, so anyway, we integrate this. So I have u minus half plus 1 divided by minus half plus 1. Okay, and then I put in the limits. So 13 to 13. So this is actually 13 to 13, 13 to 13. This is minus 2 to 2. Okay, so I work out this whole thing. So this will be half 2 u to the power of 1. Okay. So end up will be 13 square root minus 13 square root equal to 0. So this whole question is really for us to see, to just exercise our substitution now. Any questions? Okay, so with that, right, I'll then put it back into the y average. So my y average will be then 1/4 times 0 is then equal to 0, obviously. Right. Because this one, this integral is just our whole expression. So we get 1/4. Okay. Then we look at the last example. It's okay. Okay, so for the last example, we have the RMS value. Root means square. So this one normally is for for the running current. In this case, the voltage is exponential. So it will be a capacitance voltage, right? The voltage reduction due to the the current discharge in the capacitor. Okay, so now we are to find the voltage RMS value, right, from t equals 0 to 1. So this, I think in the end, this will help us to ascertain the power that is being enabled by the capacitor over the 1 second period. Okay, so let's do this. So first thing first, see there's a y square, right? Y square, right? So what I will do, normally I will do the y square. What's the y square value? So in this case, say for part A, my y square is actually v square. So v square is then equals to 1 plus e to the power minus 1. Minus t, sorry. Minus t. Okay, enlarge a bit, minus t. Okay. So now let's integrate across. So my V RMS will then be square root 1 over 1 minus 0 the time integral from 0 to 1 my v squared, which is then 1 plus e to the power minus t and t. So it looks a bit awkward, if you ask me. A bit awkward, right? Yeah. And if I were to simplify it further, I will then have square root 1 over 1 minus 0 is 1, right? Then integral of 1 plus e minus t. So I will integrate this. Integral of 1 is t. Integral of e minus e to the power minus t will be minus e to the power minus t. Then after that, I put in the limits. So essentially, this integral here, right, is the integral of this. In case there's too many expressions. And once you have this, we put the limit in square root. Okay, so with 1 minus e to the power minus 1 and minus 0 minus e to the power minus 0. So what I have will be square root 1 minus e to the power minus 1, and this will be minus will be plus 1, right? So I will end up having this 2 minus e to the power minus 1, and when I use a calculator, I will get 1.28. Remember the units, the RMS is in volts, so 1.28. I think the answer did not mention the volts. We need to put in the volts. Okay, then I move on to part B. Okay, part B, one period of the electrical voltage V equals to 3 cos pi t. Okay, so V equals to 3 cos pi t. Alright, okay, to do this, one period, right? So what it means is, if I can plot out a graph, I need just a quick recap. Of course, I can straight away do from EM1, right? So this is P, this is V. Alright, so what is 3? What is 3? What is this thing called? What is this 3 called? For trigo function? Amplitude. Amplitude, right? A. Then how about my this? This is my what's this? Frequency, right? Frequency. And then normally there's a phase shift, right? There's another thing called phase shift. Alright, okay. So okay, I won't call it frequency. I haven't got to the frequency. There's a B and then there's a C here. All right. So to find my period, period will be 2 pi over b. Right. That is to find my period. 2 pi over b. Okay. So in this case, so the graph actually will look like this. Just to draw the graph. See, right? So this is a cosine graph. Okay. So let's say the period, for one period, will be 2 pi over pi, which is then equal to 2 seconds. So what it means is, at 2 seconds, it's a one period, one cycle by itself. Of course, the frequency will be 1 over 2, half a hertz, the frequency. So every 2 seconds, I have one cycle in this case, right? And what do we need to do? So from what's the electric volt graph for one period? So I will then need to my limits. This would mean that my limits will be from 0 to 2 seconds. 0 to 2 seconds. So from 0 to 2 seconds. So this will be my so-called limits of A, this is my limit of B. Right. So again, for RMS, let me do the V square first. Alright, so V square will be 9 cos square pi t. Right. Okay, and then for cos square pi t, we will have to, for it, to integrate this, right? To integrate this, we have to use the, the cosine, the double angle formula. So if you look at the double angle formula, let me just go to the formula sheet. Formula sheet. We go, so we have to make use of this, and 2 cos square. This is the double angle formula that we need to look at. Right. So cos 2a equals to 2 cos square a minus 1. So when we go back over here, so we have this, just right at the side. Cos 2a is equals to 2 cos square a minus 1. So cos square a will be then equal to cos 2a plus 1 over 2. And since this is cos pi t, right? Cos square pi t, so then replace cos a with pi t, and it will give me cos 2 pi t plus 1 divided by 2. Okay, so far okay with this. Then for the VRMS, I'll then put into the formula, like root, the mean will be from 2 to 0, and I integrate from 2 to 0, the v square, which is then 9 cosine square pi t. And this, I will then get root 9 over 2 the cos square pi t, right? Cos square pi t, I will replace with this. So then cos 2 pi t plus 1 over 2. Then I can pull out the 2 lah, right? I can pull out the 2. Pull out the 2, so it becomes 9 over 4. Okay, then what happens is that I will have to integrate cos 2 pi t, which will then be 1 over 2 pi sine 2 pi t plus t from 0 to 2. So I put in all the values. So square root 9 over 4. So I'll put in 1 over 2 pi sine 4 pi plus 2 minus sine of 2 pi of 0 is 0, right? Then plus 0. So actually it is 0 plus 0. Then actually in fact sine 4 pi is also 0. So this is also 0. So I'm left with with this value, right? Just right here. Square root 9 over 4. 2. Okay, now let me see. Yeah, 2. Okay, so this becomes, when I work everything out, this becomes 2.12 volts. Okay, 366. When I work everything out. So in this case, we have to how about we use differentiation by part. Let Q equal to cos pi. So let's say I can use another alternate method would be let I just write at the side let U equals to cos pi t, right? So then du t, but this will complicate matters. Du dt is minus sine pi t. Then we got to figure out how to remove the pi t yeah, because sine pi we still got to put this in terms of u, right? That if we were to replace it, to put it back in. So maybe at the end of the day, maybe it's still easier to just use the zero expression to replace everything. Just let me see the P&A schedule. Alright. So currently we are on the 18 July week. We are done in chapter 4 in terms of the theoretical, the concept. So we need to look at the tutorial as well as some of the examples that I passed to you guys, right? So what we do, right? We can look at the tutorial first. So we tried section 1, section B and okay, ABC, right? So maybe for to start us off, or just to help us recap, we can do section B, right? The challenging problem, we can look at it, towards the last part. Let's just look at this. We try question 12. Let's try question 12. Yeah, then after that, we look at the revision question. So from today and the next few sessions, we will try a bit of tutorial, then we look at the revision question. Okay, let's look at the question 12 tutorial. Okay. Yeah, we can do together lah. Yeah. The 4th August. We were discussing last Monday. So next, technically it's next Thursday now. Then we discuss. Okay, to some 4th August. So that we have time to digest everything. Yeah, because a bit of indigestion, right? If you don't have time to sink in, we need more practice. Really need you all to practice. Okay, so because when you look at it, then we do together. It's a bit different from when you sit down and do it by yourself. Okay, so let's look at this question 12, and then after that we do the revision questions. Okay, the work done by an object. So now it's talking about work done. Actually, 12, 13, 14, if you look at it, it's all engineering issues. So there's work done, there's power, there's current. Okay, so the number 12, work done by an object is W, and it varies with distance traveled by the object. So work done with the distance traveled as this expression. So we're supposed to find the average and the effective work done from x equals to 1 and to x equals to 4.5. Right? So it's work done when they move from a distance of 1 meter to 4.5 meter. Okay, and if you look at the graph, it's like a slope. The work done is like a slope. The further it goes, the higher the work is being done. Right? Okay, so let's do this. Okay, so for question 12, okay, y'all can do it also lah. Y'all don't have to look at my thing. So average will be from 1 to 4.5, right? Oh, sorry, need to do the thing. Oh, you're here. 4.5 minus 1, right? Integrate 4.5, and the work done is 5x minus 5. Yeah. Alright. So actually W equals to 5. Basically it's like this. 5x minus 5. So 1 over 3.5. Integral of this will be 5 over 2 x squared minus 5x. So quite a bit of calculations. quite old school one. Oh, funny man. Wow, completed a bit too. What is it? Okay, wow. Okay, some. Okay. One super rabak. Okay, see whether you can get. Yeah, I just leave it as a reference for you guys. Algebra is horrendous. And for the remaining time, remaining half an hour or so, yeah, now it's 10:25. Please try these two revisions with the past design. Yeah, it's also on the online, the OneNote. Just try the definite integral, fixed one. So, just try fixed one first. The next week we move on to fixed. All the functions, all the functions, all the functions. For this, yeah, reference, you have to put on very good, well done. Yeah. Anyway, the exam, you guys can also download, right? So I saw it's about 30% of differentiation. The remaining 70% is all on integration. Yeah. So 30% is on differentiation, 70% on integration. So much really wrap up the integration. Okay, I'll pause the recording on Zoom. Caden, you have any questions?
Just trying to understand it. It's just very long. Yeah.
Yeah, it's very long. Yeah, correct. Okay, I'll stop the recording. Sorry, not stop here. Let me pause the recording first. Stop the recording.